Hello and welcome to the second tutorial. If you are watching this, it means you have probably completed exercise 1 and created conditions to work with. In this tutorial, we will be looking into some alternative methods to create scenarios and adjust our conditions and outcomes. Our goal for the second exercise is to combine our conditions and make them relevant to each other, thereby creating new scenarios. For this exercise, I will demonstrate my workflow to simplify my algorithm. If you try to start doing everything grasshopper at once, things can get complicated than they need to be. First, I will define some conditions like we did in the first exercise. My conditions for this exercise are interior temperature, exterior temperature, and day-night situation. Day and night represent whether there is sunlight outside or not. Don't forget you are allowed to use these conditions and come up with your own. What's important is to use data. On the right side, I have defined some outcomes, which are what happens when the criteria are met. For the outcomes, I have decided to go with two things. The first one is the window blinds, which is simply to prevent sunlight or let it in. The second one is the air conditioner. The air conditioner will be used when the blinds don't solve my problem. Again, you are free to come up with any kind of systems you want. Next, I have created a table to define scenarios. For the first combination, I have made a connection between interior and exterior temperature. For exterior temperature, my conditions are if it's lower than 20 degrees, if it's in between 20 and 29 degrees, or it's higher than 29 degrees. For the interior temperature, I have used similar conditions, which are lower than 20 degrees, or it's in between 20 and 24 degrees, and higher than 24 degrees. As you can see on the table, I have come up with 9 different scenarios. Now we can move on to the third part, matching all condition, scenarios and outcomes. I have decided on logical outcomes for all the scenarios. For example, in scenario 1, where I have less than the desired exterior temperature and less than desired interior temperature, my only solution is to adjust the interior temperature using the air conditioning to warm the room. Or in scenario 9, use it to cool the room, since both exterior and interior temperatures are above the desired levels. And of course, it's logical to keep the AC off when I have other solutions for different scenarios to save energy. Now we can start working in Grasshopper. Before I begin the exercise 2 tutorial, I want to show you my solution once more for exercise 1. Alright, to solve the exercise 1, what did I do? First of all, my conditions were the sun angle, interior temperature and exterior temperature. In this case, exterior temperature and interior temperature, I use the same formula, so I won't be explaining it twice. In this case, I will be explaining two primitive methods. I call them primitive because in the next session we are going to learn a little bit more elegant way to solve it. Now here I am going to show you the primitive solutions for this task. First of all, for the sun angle, it's pretty straightforward. What I want is very defined. I want a sun angle between 10 degrees, so it has to be larger or equal than 10 degrees, and then it's smaller or equal than 90 degrees. So I create a number slider. In this case, I have used 360 as my maximum value, so it's basically a full round. Of course, this is not a realistic condition for sun angle, but it's just to create the algorithm. The input can then be changed with a sensor data or anything else. So the first thing I did is use the larger than and smaller than components to get Boolean operations which are true or false, and it's mathematically 0 and 1. So because it automatically can be read as 0 and 1, I can use mathematical conditions or formulas with that. So in my case, I have used multiplication because I only have two values. It's either 0 or 1. And one thing I know is if I multiply these two, I have only two possible conditions. One is when both of them are 1, then it's just 1, the result is 1. And if either of them is 0, then it's always going to be 0. So I have three possibilities of getting 0. It's one of them is 0, the other one is 1, and vice versa, 2. Then third option is both of them are 0. And then of course when both of them are 1, then I get the result 1. So why do I do that? Because at the end, what I need for the open factor is a value from 0 to 1. So how does this work now? If I get here the number 1, I want to adjust my angle, sun angle, with this 1 by multiplying it and getting a result. I can put a panel here. So it's 41.33 degrees, which is a desired number. That's something I want. And then anything beyond 90 degrees is going to be 0. Also anything below 10 degrees will be 0 again. And in my case, 0 means that my blinds, my window blinds, will be open, up. So the sunlight can come in. In this case, there won't be any sun. That's the condition we created. So in the night time, I allow my blinds to be open. So then the second part is to map these numbers to match a kind of a domain between 0 to 1. What is a domain? I explained in the first tutorial. A domain is any number in between the given two values. In this case, if I say 0 to 1, it is all the values, all possible values within 0 to 1. It can be 0.0002 or 0.9998. So remapping the numbers, what does it mean? It means I have a set of values from 0 to 90, right? In this case, when I get from 0 to 90, my values are going to be something like 41, 43, 45, 70, and these I have to turn into an open factor value which is 0 to 1. Therefore, in the remapping, I get the target 0 to 1 because I have a domain, it's from 0 to 90, and I have to turn this into such a value that it has to be in between 0 to 1. So I put the target to 0 to 1. You can use any text for that. And then for the source of my domain, I use 0 to 90. And I add the value to it. So what happens is the outcome, the mapped outcome, is going to be 0.835222. This is the value that's equals to 75.17 within the 0 to 1 range. So what from 0 to 90 is going to be what 0 to 1. And in this case, it gives me the value that I can change to open and close my blinds. Now we are going to the second part, interior or exterior temperatures. This is slightly a little bit more difficult than the previous one. It's kind of messy, can be messy, but in the basic idea is same. Only difference is here I have another value now. So first of all, I use again smaller and larger than components, and I say, okay, what do I want if my exterior temperature is lower than this amount, or if it's larger than this amount. So in this case, my exterior temperature is lower than this value, it then becomes false. Or if it's lower than this, it becomes then true. Now in this case, I want to go with the opposite. Why? Because if my exterior temperature is lower than my minimum value, I want my blinds, my window blinds, to be open so the sunlight can come in, so it's going to be warmer inside. So in this case, the value that I get as 1 in my condition for my open factor means the blinds are actually down, which means it's closed. So I have to invert this boolean and turn it into false. And in this case, then I am using the boolean invert tool to create inverted values. Basically, if it's true, then it gives me false. If it's false, it gives me true. Now the second part is same. I use the multiplication to get the larger than value and my smaller than values inverted version. Here I get the number 0, for example, and then I'm going to be using an addition and an AND parameter. Why? Now there is this slight condition when I have it large, if it's larger than that, so if it's larger than 25, in this case 26, this is true. Okay, that's fine, that's what I want to have. It's larger than 20 anyways, but the thing is, after 25 I want it to be closed always. I just want it to be open and close in between 20 to 25. So if it's 22, for example, in this case 20, 22, 25, this is a desired condition now. So do I have a larger than or equal to? No, it's false. Do I have smaller than condition? No, it's also false, but I use the inverted version because I need the opposite value, so it becomes true. Then I'm using another inverted parameter to get the larger than value to have inverted into a true form. What it does is actually let me create a condition saying if it's larger than 20 and it's smaller than 25, you can create a smaller than factor also here, another tool, another component, but it's easier to just use an inverted value, because if it's not larger than 25, it means it's lower than 25. So in this case, if it's lower than it, this inverted value means it's lower than 25, and this means it's more than 20. And if both are correct, if I get both values, true and true, it's going to be true. If either of them is false, it's going to be false. So in this case, it's true, and my result is 0. It's 0 because it's not larger than 25, and therefore I get the value 0. And then therefore I'm using an addition. In addition, may not work in many cases, maybe, but because we are only working with zeros and ones, and this AND function only works when the result is 0, I will always get either 0 or 1. So therefore I can use it. In this case, the result is 0, the AND function result is 1, and when I add them together, it gives me 1. And then I use this again for multiplication with my exterior temperature value, which gives me again the values that I need. So when I look at that, the mapped version, I get the value desired. So 22 degrees exterior temperature then gives me, okay, right, Something happened. I went to the interior. Okay. 22 degrees exterior temperature gives me 0.4 open factor value. Now, what happens if I go below 20? It becomes -4, which is wrong, right? Because in this case, I want 0. But because my domain is actually starting from 20 and ends at 25, this is the 20 to 25 target source. Anything below that is going to give me something below 0 in the equivalent. Now here is the catch. If I use the clipped version, it's going to always cut it at the bare minimum and total maximum. So if I go over 21, it's going to start giving me the values for my open factor. And if I reach 25, it's going to be 1. And anything beyond that will stay as 1. If I use the mapped version, it's going to continue adding with the same distribution between 0 to 1. Therefore, I'm using the clipped version for my open factor. Okay, now we can start with explanation for the exercise 2, and I'm going to be actually demonstrating my solution for this one. It's up to you if you want to use this exact solution and just copy what I did, but I suggest you come up with your own system. But repeating this would probably also give you the same benefits. Just please try to understand the mentality behind it, because as I said before, we are using here made up inputs. The inputs and conditions that we selected are just for this exercise, and in real life might not give the most optimal results. Later on we can start using Excel files, sensor data, data from the internet that we get for the weather values, for I don't know, sun radiation, sun angle and such. This can also be used with BIM, which would be then a very nice workflow as well. But like I said, for now it's just made up values. So I already showed you in the beginning of the tutorial this tables that I've created in Excel, and I'm just going to explain how I use these Excel tables to come up with my grasshopper conditions. As you remember, in the previous exercise we had a bunch of combined tools. This time we have only this much, and this is actually pretty elegant, and I'm going to show you why it's that simple. So I zoom in, and as you see here, I have always used if conditions. And where do they come from? They come from this table here on the left side here. So to explain that, I first created the exterior temperature conditions, then I have created the interior temperature conditions. What are those? The first condition is that my X value for exterior temperature is smaller than 20 centigrade degrees. So in this case, I put my minimum value, I put my exterior temperature, and I put my maximum value for the later. And I create an expression. What is an expression? If you go under maths, under script, you have expression. Or you can double click on the canvas and type in expression, and you can use the same tool again. So first of all, what I need to define is my variables. It automatically comes with two variables, x and y, and in my case, okay, I keep them both and rename them. Their name is important because this name you will be using in your formulas. So for my first variable then would be x for my exterior temperature, and for the minimum value I used C for cold or cool. Then in the formatting part, I double click and it opens up this picture, this monitor here, and here on the right top corner, if you click on this, it shows you what functions you can use and how to actually write them in this dialog down there. In my case, I use a very simple if conditions. What is it? If my x value, exterior temperature, is smaller than C, in this case the minimum value, but I want to make it parametric. Alternatively, you can also type in 20, that would work. I put C, and then this is my condition, right? I put a comma, and then I say 1 if it's true, if it's false, 0, and then I close my formula. And then there is a syntax error which says left hand value of operator is null. Then now this is fine because x and c values are null because we haven't attached any parameters, any inputs to them yet. I say okay, and then I put my minimum value to C, and I put my exterior temperature value to X. And as you see now, the syntax error is gone. No syntax errors detected in expression. And this gives me a result as 0. Why? Because my exterior temperature right now 23. If I go below that, if it's 19, it becomes 1. Now let's use this same system to create these two values. The last one for the higher temperature is exact same. In just here, instead of making it smaller than C, we are making it larger than H. In this case, H is hot, and then the 1 and 0 are still the same. Now the more tricky part is the middle one, because we need then two conditions. You might tend to do this, or just type in there if 20 is smaller than X, smaller than 29, if true 1, if false 0. This wouldn't work actually. I don't know the exact reasoning for that, but just this tool doesn't accept this. In this case, what you can do is actually use first C is smaller or equal to X, and right here and put in parentheses again X smaller or equals to H, and then close the parentheses for both, and then it's true or false again. So what does it do is, if X is smaller than the minimum value, and if it's smaller than the maximum value as well, if X is larger than the minimum value, and then if X is smaller than the maximum value, it's true. In this case, let's try 23, 24, then it's true. So what did we reach there now is this. We have created this, we have created this, and let's create the last one, is this one. Like I said, we just do X larger than H, and that's the third one. Now we have to create the same system down here. I give them its same minimum and maximum, different minimum and maximum values. If you want, you can only use only one minimum and maximum value. It's up to you. And in this case, for the interior temperature, I use the value Y as my variable, and the rest is exactly the same. So in this part, everything is same as here up there. It's just instead of X, I'm using Y. Can't I use X? I can, but it's good for me to have a consistent naming system, because I used here interior temperature Y. Actually, I realized I used here X also. Let me correct it also. Yeah. So basically it goes like this. And as you see here, I have 9 scenarios. What's the scenario? First scenario, for example, is when my exterior temperature is lower than 20 centigrade degrees, and my interior temperature as well is lower than 20 centigrade degrees. So what is it? If it's smaller than this and smaller than this, then I'm using an AND condition. It's called gate AND, and I say if it's smaller than 24 exterior and if it's smaller than 24 interior, give me 1. In this case, this is false, but to create the first scenario, let's change the values. Interior temperature 16, exterior temperature is 11. So my condition is done and it's true. Now I have the scenario 1 now. And let's try something else. Let's try scenario 5. For scenario 5, I need for exterior temperature, it's in between value, and for interior temperature, again, the in between value. For the first one, for A, I put my exterior temperature, and for the second one, for the B, I put again the in between condition, and it gives me the result false right now. But if I put both of them in between the correct values, exterior and interior, then I get the value true. Then this is scenario 5. So what I created basically here then is all 9 scenarios. If I select them, the lines are hidden, that's why it looks more organized, because when I activate them you will see those spaghettis here. And I really don't suggest you work with spaghettis on Grasshopper, because things can get really complicated. It's always best practice to work clean. So for my first scenario, I get the value false, then I don't care. I need to find the true version. So in this case, last time we put it to the true version for the scenario 5. And here I have created day-night selection. So when I change this, it changes values. I show you here my scenario condition table. And here I see, okay, for scenario 5, what do I need? During the day, I need my blinds up. Why? Because in scenario 5, I have desired values for interior and exterior. And during this scenario, during the day, it's up because I want sunlight in. Of course, when it's possible, we always want our rooms to be lit by sunlight. It's always good and positive energy, and therefore it's desired. Of course, you can keep it down as well. For the temperature, it wouldn't make much difference. Only thing is, since it's up, it means in time, if my exterior temperature is higher, my interior temperature can go up. And in that case, I might, I might actually go to scenario 8, where my interior temperature is higher than 24 degrees. Don't see these scenarios as static values. They are not static. They are constantly changing with the changes we come up here. So if I want to create a intelligent system, the data requires to be read almost instantly, always, or at certain intervals. So every 10 minutes or 15 minutes, so it checks again and finds the scenario related to that moment. So I don't see this for a whole day situation. It will constantly changing. So like I said, for the scenario 5, I create this day-night thing. So what is this button here? Under the params, you have the input values, and here you have value list. I put one here. When you right click on it, you have 4 different options. Let me do it here bottom, so we have some space. And if I put it a checklist, I can then check more than 1 values. Then I can use a drop down list to select one. Then I can only select one of them. Then I can go with value sequence. There you can move them like this as well. It's almost the same thing. And then value cycle. So I haven't used these, so I can't say much. But I usually use the drop down or the checklist. And when I right click, I can go for edit. So this shows me what 1, 2, 3, and 4 actually means, because these on the left part are only names. What does it mean? I don't care what's written here, either 1 or 2. You can put the correct values like 1 and 2 as numbers, or for the 3, for example, it's 2 square, which is 4, then minus 1 is equals to 3. Or if I have 4, 4 is square root of 16, which is 4. I can delete those, and I can also put here day and night. And let's say in my conditions I actually want booleans, so I can say 1 for the day and 0 for the night. So here I might be changing the day and night situation, but what I'm doing is basically exact same as using a boolean toggle, which is false and true. But this is more elegant, because here then I can right click and change the value list to day night as my title here. So this would look like a native tool to change from day to night. So is it enough alone to do that? No. Like I said, this is a boolean, so I can create again an AND gate. And here I can say if scenario 5 is true, so if I'm in the scenario 5, what do I have here? I have day and night conditions, right? And I say when it's during the day, it needs to be up as a text, or it needs to be night as a text. Or I can get values like 0 or 1. Now, let's hear what I did. I have created the formula. Then if C is true, then I get the text. So to put a text, you have to put these quotation marks here. So in the syntax, it reads them as a text. I get up, and if it's false, I get up again. In this case, my curtains are always visible as up. And let's go to the other part, is the air conditioner. In this case, I want it to be off, which is what I desire. So it's up to the user in this case. Therefore, I put my formula as if the scenario is false, it doesn't show anything. If it's on, so if the scenario is active, if the scenario is true, please, the air conditioner is off. What does it mean that I have no value here is to see that when the scenario is not active, I don't get any value here. It's up to me if it's on or off, basically. To show a better example, let's say with some extra information, let's say the scenario 1. Let's create the scenario 1. So right now the scenario 1 is true. So I can say here it's during the day. So it's basically cold outside and inside as well, but there's sun outside. And here my condition is if the day cycle is true, I mean the combined values are true, my blinds are up. If it would be the night, for example, it's going to be down. The reason for that is during the day, the sunlight would give me extra heating anyways. If it's not enough, I can still use the air conditioner, of course, but I would want the warm air to come in. But if it's night, using the blinds would at least prevent the cold from coming inside even a slight degree. So keeping them down would help me keep inside a little bit warmer. So I want them to be down. So, and then the second part, because in this scenario the sunlight would probably not be enough to warm the interior, because the exterior is obviously cold as well, I need air conditioning. So I say if it's true, air conditioning is on. If it's false, then don't show anything. And if it's false means anyways that this scenario is not relevant. I hope this is clear, because this is what I meant by organizing it early on. When I create the scenarios here, as you see, creating them in Grasshopper was quite straightforward, elegant, and simple. And after I created those, basically what I did is exactly what I see here in this list for each scenario. And at the end, I get my desired results. Now it's up to me whether I want to use 0, 1 conditions to use for the open factor. I can also try to create some values in between. So for example, if in scenario 5 I have the desired value blah blah, then the blinds will be up and down up to the temperature. These kind of extra conditions I can create, of course. It's totally up to me. What's important is to coming up with the scenarios. Then later on it's just formulas for elegant presentation. I hope this was clear. And this actually gives you a data to use in your reports then when you have different scenarios, and you can show, okay, what happens when it's true and it's active and when it's not. And here is a very easy way to check it quickly. I hope this would be helpful in your task, and I look forward to hear from you also with the new exercise, and then see you on the next time we meet.